Textbooks open to page 174. And homework out as well. You did numbers 1 through 8. They're on page 174. We wrap up a little bit more review here on linear equations before we change gears with what you looked at last night in your homework reading, looking at variations. So we'll see how we did on this, and then like I say, we'll get right into our discussion of variation. Oh, it did say graph. Okay. All right. Oh my. Okay. I think you were. Never mind. All right. All right. So let's go ahead and take a look at these here. Number 1 gave us the equation 4x negative 6y equals 3. And this is written in the standard form. We mentioned the standard form in our last lesson. But it wanted it in the slope-intercept form. The key to slope-intercept form is to get the y by itself. I'm going to pull the double switch here and say that 4x minus 3 equals the 6y. And then when I divide everything by 6, well, I'm getting y is equal to 2/3 x minus a half. How many have that as your slope-intercept form equation? Any questions on that? For the sake of time, we'll show the quick sketch here of what the graph should look like. You're going to start at negative a half, so that's going to be right here between the 0 and the negative 1. From here, I'm going to need to rise 2. Well, from here, rising 1 would be to the positive half. Rising the second would be to the 1.5. And once I get here, from here, I'm going to run over 3. So I'm still lined up here, but over 3. And then just use your straight edge, if you have one, to connect the dots and get something like this. And this probably looks a lot like Brandon's because there wasn't a straight edge. Yes. Questions on this? How many have a line that looks like that? Any questions at all on graphing slope-intercept form? Been a little while since we actually graphed anything. We talked a lot about theoretically what would happen with lines and graphs, but hadn't actually done it. Questions? Let's look at the next one where we had a 7x negative y equals negative 12. Again, I'm going to go double switch here and get the 7x plus 12 is equal to the y. Now this is technically already slope-intercept form, though I may want to rewrite it y equals 7 over 1x plus 12. Don't necessarily have to. This is going to be a pain, though, because my y-intercept class is 12. So I'm going to have to go into 1, 2. I picked a really big gap for 1 and 2, didn't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on the y-axis, remember. And then my slope calls for me to rise how much more, class? 7. Here's an example I'm doing that. Okay, I've already made it this tall. So instead of rising 7, class, I'm going to go in reverse. I'm going to fall 7. 1, 2, 3, 4, 5, 6, 7. But then I also have to reverse the run. Normally, I would run which way? To the positive, right? But since I reversed the 7, I'll also reverse the 1. I'll actually run backward 1 unit here. And so my line should look something like that. And how many had a line that looks something like that? By something like that, I mean it looks like that. I mean yours was like way over here on the x-axis. You put an x-intercept of 12 instead of a y-intercept of 12. You see what had happened was. Yeah. Questions on this? Questions on this? All right, yeah. All right, let's go ahead and talk through numbers 3 through 6. They give you 2 points. You want the slope-intercept form of the equation. What did you get for number 3, Kendall? Kind of a weird-looking answer.
Y equals negative 13.6 plus negative 74.6.
Oh, my. Maddie? Okay, don't forget the x. The x is part of it. Y equals negative 13/6 x plus 11/6 would be correct. So you got the correct slope, Kendall. Something just happened in getting your intercept there. But yeah, y equals negative 13 over 6 x, and then positive 11/6 is your y-intercept. Number 4, back to Kendall for redemption.
Y equals 7/8 x negative 21.
On number 4?
Yeah.
You got a slope of 7/8. Oh, I know what you did, Kendall. Look at your points there in your textbook for number 4. You used the negative 5 and the 0 somehow? Or the negative 5 and the negative 2 together somehow come up with a 7, and you use the negative 5 and the 3 together. So yeah, you kind of Jumped all over the place there. Michael, what did you get for number 4?
Y equals 1/4 x minus 3/4.
Good. Y equals 1/4 or 2/8 initially as your slope. Y equals 1/4 x minus 3/4. All right, third tries the charm. Kendall, number 5. What did you get?
Y equals 1/4 x positive 3.
So close. Genesis, helper?
I have y equals 1/4 x plus 3 3/4.
Good. Or y equals a 4th x plus 15/4. But 3 3/4 is not a problem for your intercept. All right, you know what they say, 4th tries the charm. Kendall, what did you get for number 6?
Y equals 1/9 x plus 7.
Audrey, helper?
I got y equals negative 1/9 x plus 25 over 3.
There we go. Y equals negative 1/9 x, positive 25 thirds. All right, Kendall, pick one of them for me to work for you.
Let's see. I think number 4.
Number 4? All right, so we have the -5, -2. We have the 3, 0. Remember, the first thing you'll find is the slope. You gotta put the y values in the top. What are your y values?
-2 and 0.
And you're gonna subtract them, remember. So -2 minus 0. And then in the denominator, since you started with -2 in the top, you've gotta start with,
So -5.
and you're gonna subtract the
3.
3. Well, -2 minus nothing is,
-2.
and -5, negative another 3 gives you,
-2.
from here we're gonna cancel the 2 negatives and reduce 2/8 down to,
1/4.
from here we'll pick one of these 2 points.
3 and 0.
All right, and we'll say y equals mx plus b. Now, of course, the y value we're gonna replace with
0.
0. The m gets replaced with,
1/4.
the x gets replaced with,
3.
and we'll have the plus b. Well, 3 times the 4th, nothing cancels, it's just,
3/4.
but I have to move it over to the other side as a,
Negative.
so there's my b value of -3/4. Well, I know m, I know b, so the equation,
Y equals 1/4 x -3/4.
and there we go. Does that make sense? Just gotta be careful. There's a lot of little places we could mess up. I'm not sure where all those places were. It was probably a small mistake each time because you seem to understand the process just fine, but very human on the homework. All right, questions on that? All right, let's take a look at number 7, and you were asked to find 2 answers. First of all, they wanted the equation of a line parallel to the given line through the given point, and then for the second part, they wanted the perpendicular to that same line through that point. Number 7, what did you get for your answer to letter A? Kendall.
Number 7.
7, part A.
Okay. Y equals 3x plus 28.
There we go. It's like stuff like they say. 5th tries the charm. All right, y equals 3x plus 28. Poor Kendall. I don't know why we're picking on her today. Not meaning to. And then letter B, the perpendicular, Brandon.
Y equals negative 1/3 x plus 8.
Good. Y equals negative 1/3 x plus 8 is correct. Seeing a few people changing some answers there. Do we need to see either of those worked, A or B? All right. Abby, number 8, what did you get for part A when you found the parallel through 3, -5?
2x minus 5y equals 31.
All right, if you did it in standard form, which is what the book said to do you have your slope-intercept answer by any chance?
Yes. Y equals 2/5 x minus 6 1/5.
Good. Y equals 2/5 x minus 6 1/5 or minus 31/5 would work as well. What about part B, the equation of the perpendicular? Maddie? Good. Y equals 5/2 x plus 5/2. Negative 5/2 x. I'm not sure if I said that. Y equals negative 5/2 x plus 5/2 is correct. It's a long shot. Was anyone perfect on the homework? You got it all. Okay, guys. Okay, good. No, your graph. I remember your graph. Don't get. Oh, other than the graph, I was perfect. Other than all the mistakes I made. Kendall's like, yeah, me too. Just discount my mistakes. I was perfect.
Do I get 100 grand?
No.
You should go check it.
We do that instead of a sticker.
Oh, what my sticker?
All right. Anyway.
Sticker?
All right. But you weren't qualified for a sticker. It was a torn sticker. That means I get a small bite of your 100 grand bar first.
I didn't have a sticker. That's what I asked.
Oh, yeah. After class. Okay. We said this already. All right.
I'll take his other half.
I'm taking the other half. All right. Let's go ahead and review some things that we're going to use today as we discuss variation. You should have read about it last night in your homework reading, and two types of variation we'll look at in a moment. But before we do, remember in any literal equation or any formula, let's take, for instance, a equals pi r squared. Okay, we're talking about area of circles in my 8th grade class, and bears little quick review since it's been a little while since we did area of a circle. The thing that you generally solve for in the equation is the area. And the area depends on whatever radius you pick. For instance, if I draw a circle with a compass, the bigger I open the compass, that bigger the circle is going to be. It just depends on how much I open the compass, what the radius is. So we would call the area in this formula or in this equation class what kind of variable? Since it depends on the radius. The dependent variable, right? Now the radius is completely up to me if I'm drawing it, right? How much do I feel like opening the compass? Open it a certain amount, that's how much I chose to open it. I had a free choice. We would say the radius here is the independent variable, right? You could have more than one independent variable. Technically I have two. I have r and I have r. And then the pi right here. Well, that value doesn't change. I don't get to pick the value of pi. It's 3.1415, and it just keeps on going. So therefore, we would say pi class is a constant value. A constant value. It never changes. If I have the equation p equals 4s. Here, class, what would be the constant? 4. What would be the dependent variable? The p, and the independent variable is the s. I want to make sure we understood those terms before we get into variation. And that's the next term for you to write in your notes. Variation. Variation. Variation describes the relationship. Variation describes the relationship between the dv and the iv. Describes the relationship between the dv and the iv. We call it the dependent variable because it depends on the independent variable. It varies dependent upon the independent variable. But, how can we describe this variation? Two types of variation that you should have seen in your reading. We'll talk about it here, get them in your notes. The first is called direct variation. Direct variation. Now, technically, this would be true of the perimeter of a square. As you increase the length of the sides, the perimeter of the square, did I say area of the square? Perimeter of the square varies directly with it. You double a side, perimeter also is going to double. Okay? As the side changes, so does the perimeter. Area of a circle, or even area of a square, wouldn't quite be the same way. Because as you increase the radius, if I double the radius, I don't double the area, I would quadruple the area. So that's not quite direct variation. Here's your definition. Direct variation is present whenever the dv is a multiple, I can't spell, multiple of the iv. If the dependent variable is a multiple of the independent variable, we have what's called direct variation. Here's the form that describes this relationship. Y equals kx, where y would be our dependent variable, x the independent variable, and k would be any constant value. We use this letter to represent the constant of variation. You can see how p equals 4s would fall into this form, right? P equals a certain number times the independent variable. That would be direct variation. It varies directly with it. The other type of variation that could be present, one of the more common forms, I should say, there's all kinds of different forms, but there's logarithmic forms and linear forms, stuff like that. Well, another common form, we have what's called inverse variation. Inverse variation. Now, on its most basic, we think inverse meaning one goes up, the other goes down. But in its strictest sense, inverse variation is present when the dv is a multiple of the reciprocal of the iv. When the dependent variable is a multiple, not of the independent variable, but of the reciprocal of the independent variable. So the basic form for inverse variation would be not y equals kx, But y equals k times 1 over x, or we could say k over x. Now this is the way that the book presents it. But let's face it, seeing a multiple of a reciprocal is hard. So I'm going to make life easy, because I'm lazy. If I were to cross-multiply this proportion, think of this as a y over 1, I would get xy equals k. And here's a better way, perhaps, to think of inverse variation. Technically, this is the definition, but another way to think of it is that the product of the variables is constant. The product of the variables is constant. And to me, that's an easier way to look at inverse variation. Whatever the variables are, they always multiply to the same thing, because that to me is easier to see. Look in your textbooks if you go to page 169, and let's take a look at these types of variation. One of the most basic ways you'll see variation is they give you a table of different x and y values. What I look for then is, are they both increasing or decreasing together? Or does there appear to be a constant product? We'll look at the numbers. 0, 0, 1, 4, 2, 8, 6, 24, 7, 28. What's always the relationship we see, class?
1 to 4.
Okay. In other words, if you multiply the top, the x, by a 4, you'll get the y, right? So we could say here that y is equal to 4 times x. Do you see that that is the form for direct variation? Make sense? Therefore, when it asks what's the constant of variation, that's this number. It's the number that shows their relationship. The constant of variation would be 4. Easy enough? Turn over to page 171. Here they give another table of values. Notice here they've got a -3, -2, -2, -3, 2, 3, 6, 1, 12, a half. It seems like it's kind of all over the place, isn't it? But look at the two numbers. Don't try to multiply one by the other. Just notice they multiply in the first case to give you what? +6. What about the next case? What about the next case? And the next case? And the next case? Always 6. The product of the values, x, y, equals 6. Now, this is the form that I see readily. However, the form calls for a y by itself, but that's now easy. To get y by itself, just divide the x away, class, and we'll say that y equals 6 over x. In other words, 6 is the constant of inverse variation because you'll multiply 6 times the reciprocal. But who sees, oh yes, if I take the reciprocal of -3 and multiply by 6, that is -2. Not me. And I'm pretty smart. I'm smart enough to figure out, the product stays the same every time. So to me, that's the easier way to look at inverse variation, but technically it is true. 6 times the reciprocal of the x value always gives the y value. 6, our constant of inverse variation. Do we see that? Questions on these two types of variation? Now, practically speaking, yes. As the x's get bigger, we see the absolute value of the y's getting smaller. I guess you could say that as well, but yeah, anyway. Turn the page 173. For numbers 1 through 4, all they want you to do is find the constant of direct variation for the table. In other words, what do you got to multiply the x by to get the y? At your seats, do 1 through 4. Page 173, 1 through 4 at the top. And the relationship is, what are you multiplying x by to get y? They're not asking for the equation necessarily. what times x equals y. We're assuming y is the dependent variable. Number 1 really is straightforward. What are we multiplying the x by to get the y? Audrey?
1/6.
We're multiplying by 1/6. So 0 times a sixth is 0. 1 times a sixth is 6. 3 times a sixth, no. Not multiplying by 1/6, we're multiplying by 6. We would say that the y value is equal to 6 times the x value in each case, right? So the constant of variation is 6. How many had 6 for number 1? What about number 2? This one's a little bit more challenging, Genesis. What did you get for this one?
-3.
Good. If we take a -1 times -3, it gives us 3. We take a 1 times -3, -3. 2 times -3, -6. 5 times -3, and so forth. So we could say that y is equal to -3 times the x value. How many had -3? For number 3, this one's a little more dicey if you overthink it. What do you multiply -3 by to get -3/4? Or 5 by to get 5/4? Or 9 by to get 9/4? Michael?
1/4.
1/4. You're just dividing all of those numbers by 4, even the ones where it's less obvious, like 2. Well, you take 2 times a fourth gives 2/4 or a half. 6 times a fourth gives 6/4 or 3/2. So y equals 1/4 of the x value. How many had 1/4 as the constant? That one a little harder because it came out of fraction. Does that make sense? Looking at number 4 now. Volunteer. What do we have to multiply the x by to get the y? Abby?
-1/3.
-1/3. We see, of course, 4 to 4/3, well, times a third. Take a third of 1, take a third of 3, take a third of 8, take a third of 11. But the sign is different every time. Well, that indicates we must have a negative. So y equals -1/3 x. So -1/3 was our constant. How many had that constant of direct variation for number 4? All right, questions on 1 through 4. Do you kind of feel like now that you've tried it a few times, even if you didn't get them, do you feel like you understand it better now? Questions at all? All right, let's drop down to 9 through 12. These, they tell us, are inverse variation, though we should be able to tell that pretty easily. It's inverse. So the question is, what's the constant variation? Remember, the easiest way to think of it is, if you multiply the x and y, it should be the same number every time, and that's your constant. Do 9 through 12. Find the constant of inverse variation on 9 through 12. Technically, the number you would multiply by the reciprocal of x. And what do you get when you multiply the two values, x and y? Brandon's got them. Maddie's got him, Abby's got him, Michael's got him. And let's take a look. Number 9. What is the constant of variation, Maddie? 4. Because every time you multiply, you always get 4. So that's the constant of inverse variation. What about number 10, Kendall? What's the constant of inverse variation? -10. You multiply those, you always get -10. Look at number 11. What's the constant of variation here, Brandon? -2. Because when you multiply those together, you always get a -2. What about number 12, Audrey? 1. Because you multiply, in this case they are reciprocals, the k is 1. Here y literally equals k over x, or 1 over x. So a k value of 1. Questions on the 9 through 12? All right, now the more practical way to use variation, this is what we're going to be looking at more in our next lesson, is taking word problems and extrapolating them out. Some of them are really basic, where you really don't do much with them. Like, for instance, number 5. Go ahead and read number 5, if you would, Genesis.
Let C and D be directly related such that D equals 16 when C equals 4. Find C when D is 28.
All right, so it says let C and D be directly related. So that means we're going to go with this form, y equals kx. But it's not y, x, and y class, it's C and D. So we're going to let, instead of y equals kx, we might say C equals kd, or D equals kc. It really kind of is up to you which way we want to go. Genesis, first or second form? First. All right, so we'll go with C equals kd. And it says let them be directly related, so this is my formula, such that D is 16 when C is 4. All right, question. What is the constant of variation then? Genesis? What do I do to solve for the k?
Divide by the k.
Well, I can't divide the k away, just solve for k. Divide the 16 away, right, from both sides. And that's going to mean k is equal to 4/16, which is, class? There we go, she got it, 1/4. K is 1/4. Then they say, okay, now that I know that k is a fourth, my relationship doesn't have to be vague. C equals kd. They gave me enough information to know that k is a fourth. So now my formula is C equals 1/4 d. Do you see that? So we start off with its direct relationship. It's this. They gave me more information, I know the k. All right, if you know the k, now you know the true formula. But, finishing it out, it says, now find C if d is 28. Well, class, you can probably do this in your head. What is C if d is 28? 7, because a fourth of 28 is 7. Does that make sense? Look at number 6. Read that if you would, Michael.
Let R and W be directly related such that W equals 4 when R equals 8. Find R when W is 32.
All right, again, we're going with a direct relationship. So instead of y and x, we'll go with r and w. How do you want your formula to start out looking here, Michael?
W equals KR.
W equals kr. And they give us information so we can find k. They tell us w is
4
when r is
8.
8. All right, if I want to solve for k, I need to divide both sides by
4.
If I want to solve for k,
2.
I need to divide away the
8.
8. There we go. And I'm going to get k is equal to
1/2.
1/2. All right, so let's get a less vague direct relationship. Since I know the constant, I can say that,
32 is...
well, w equals a half r. Make sense? That's my actual relationship now, because I know the constant of variation. So if I want to solve a second problem, which it does, it says find r if w is 32. If I want to find the r, what am I going to have to do now?
Divide with the 1/2.
Divide by a half or multiply by the reciprocal of 2. What is r, class? 64. But there's my equation based on this constant variation. There's the answer to the other part of the equation. Make sense? This is the kind of stuff we're going to be working on in our next lesson. For homework this evening, I'm going to give you a short review assignment that actually doesn't have too much to do with variation. Page 180 in the review section, do numbers 1 through 6. Page 180 in the review section, I want you to do numbers 1 through 6. Page 180, the review, numbers 1 through 6. We'll take a look at that in our next lesson. Also continue this discussion of variation tomorrow. Have a wonderful rest of your day, and you are dismissed.